Okay, so this week I've given you an introductory lab to do with R. Okay. So what you're going to have to do is on your computer, you're going to have to go and search for R. Okay. And your very first web link is going to be this. Alright? What is this here? Molar gas constant. Okay, we're not going to worry about that. Chemistry. We're going to go to the R project for statistical computing. Okay? And then you're going to download and install R. So you go over here where it says download and packages, but they call it CRAN, for like Comprehensive R Archive Network. Okay? And scroll down to the USA, and we've got a few servers. One is right here on UCLA's campus, part of the R network. And you click that, and then you download R for Mac or Windows, whatever you have, or Linux. Okay? It runs on all on those three systems. Okay. If you have something else, I can't help you out. Okay, so you download, and then Okay, I'm assuming you guys know how to install software. So you do that. Okay, so you got to download and install R first. Once you do that, go back to Google and search for. Well, I can search right here. Search for RStudio. Now, RStudio is optional. You don't have to use RStudio, but what it is it's an interface that sits on top of R. Okay, you can run R just fine. It looks very plain, but there's no problem with that. If you install RStudio, it sits on top of R, and it just adds some buttons and menus that you can use to, I guess, make it a little bit easier. Okay, because R was originally used from a terminal setting. Okay, so it's all just text-based, and I mean, when you download and install R, there's a few menus, but it's not so nice. Okay, but you can go to RStudio and you do that. Okay, and then you say, okay, I want to download RStudio, and you just follow the links, and it says, oh, I see that you're running Windows or whatever, and you download whatever you want to download. Okay. And then you install that. Okay. Again, you have to install R first, and then you have to install RStudio. If you try to install RStudio without installing R first, it's gonna complain. It's gonna say I can't find R. All right, and then you run that. Okay. 99% of the time it works just fine, no problem. You might be in that 1% where it doesn't work. Okay. And if that happens, let me know. We'll try to figure something out. I have, as an instructor, I get web access to this thing for you guys. And this is what it looks like when you start it up. Okay. And you can see kind of this terminal setting where you just type commands in here. Okay. And you can just start off by saying, what is 2 plus 5? All right. And you hit enter, and it reports back 7. Okay. What's this bracket 1? All right. The bracket 1. So R is designed for statistics, which means that it can handle lots of data. And so sometimes you're going to give it multiple numbers all at once. And then it's going to give you back multiple numbers all at once. And when that happens, it puts out a bracket saying this is the first element. And if you've got a whole bunch of things, like here's a command that's going to produce a whole bunch of numbers. Okay. Alright, so here's a whole command that produces a whole bunch of numbers, and it's basically I told it make a sequence from 1 to 400 and increment it by 4. So it gives me back a bunch of numbers, and it says, okay, well the first number that I'm giving back to you is 1. The 12th number I'm giving back to you is 45. And the 67th number I'm giving back to you is 265. So on and so forth. So that's what that does. So that's why you see the bracket 1 for a lot of your answers. Okay, anyway, on the web page, in this week's homework, I say check out, you're going to do this as part of your lab, and you can read these links, and there's a few videos and stuff that get you started here, okay? Now, what I want you to do is this binomial and normal distribution. We can use R to answer questions about the binomial and normal distribution here, okay? So one command is dbinom, okay? For any kind of probability distribution, there's usually a family of 4 commands, but the one that we're going to use is dbinom, okay? And this is going to give us the answer to a binomial probability question. So let me just put in a comment, okay? So if I put a pound or a hash key or whatever in front of something, R just ignores it, okay? So this is going to be what is the probability, or if I flip a coin 10 times, what is the probability of 7 tails? Okay? So the answer to that is going to be dbinom, and I'm going to say 7 is the number that I'm interested in. The number of trials, n is equal to 10, and the probability of a success, p is equal to 0.5. Yeah. Sorry. It's not, oh, it's size. I'm sorry. Size is equal to 10, so I apologize. Size equals 10, and I write probability equals 0.5. And there's my answer. Okay. I'm used to the shorthand, so that's why I forgot. I apologize. Okay. So normally I would just write dbinom 7, 10, 0.5, okay? This is shorthand, okay? Because R is expecting 3 numbers, okay? It's expecting the number of successes, the number of trials, and the probability of a success for a single trial, okay? And because it's always expecting those 3 numbers, you don't even have to say size is this and probability is this, okay? You can just write 7, 10, 0.5. And it's going to give me the exact same number. Computer is frozen. There we go. Okay. That's weird. All right. And anytime, if you need help, you can always hit question mark, and you say, I've got questions about dbinom, and when you do that, the help will pop up over here. And you can say pop out, and it lists it up, okay? And it says, okay, there's dbinom, and there's these other functions which we'll talk about in a moment, okay? And it says, and these are the numbers it's expecting: x, size, probability, and here's other options that you can give, log, and things like that. And as long as you give the numbers in this order, you don't need to specify the size and probability. Okay? If you want to specify the numbers out of order, then you have to write down size equals this and probability equals that. Okay? Now be careful. R is case sensitive, and if you make a tiny little typo, you're going to get the wrong answer, or it's going to give you an error. Okay? Like I used n here, and R got angry at me. Okay? It doesn't know. It doesn't know that n is the same thing as size. All right, and we asked something like, okay, well, what's the probability of seeing 7 or more, 7 or more heads, or 7 or more tails? So I can answer that by doing d binom 7, 10.5 plus d binom 8, 10.5, and so on and so forth. At least I can use copy and paste, and make my life a little bit easier. But this is not that much easier, but here's the answer that we got. Okay? But we can do this. So there's a few, again, I told you R can handle multiple numbers and things like that. So there's, if you use the colon key, okay, this 7 colon 10 represents the numbers 7 through 10. Okay, so if I do 7 colon 10, it returns back 4 numbers, 7, 8, 9, 10. Okay, so instead of having to type this whole thing out 4 times like that, I can do d binom 7 colon 10, 10 comma 0.5, and it's going to give me back 4 numbers. This is the probability of seeing 7 tails, 8 tails, 9 tails, and 10 tails. Okay? Are we following me okay? All right, so then, but I'm not interested in these numbers individually, I just want to add all of them together. So what I'm going to say, tell R, is anytime, so I can use the function sum, and whatever numbers that you put into the function sum, it's going to add those numbers up. So I'm going to put sum around d binom this thing, okay? So this command, d binom 7, 10, 10.5, represents these 4 numbers. And by putting sum around it, it's going to say take these 4 numbers and add those up. And when I do that, what am I going to get? I'm going to get the answer that we got earlier. Okay, is that all right? So I given you some very basic exercises to use R and this d binom stuff. You can try that out. There's another function called p binom, and basically, whatever number I put into p binom, it's basically doing sum of 0 to that number. Okay, so if I do p binom 6, 10, comma 0.5, this is asking R, what's the total probability of seeing up to 6 tails? So that's 0 tails plus 1 plus 2 all the way up to 6. So this thing is p binom 6 is exactly equivalent of d binom 0 through 6 summed up. Okay? And remember, this thing, when I ask the question, what's the probability of seeing 7 or more tails? That's the complement of what? Seeing between 0 and 6 tails, right? Because if I didn't see between 0 and 6 tails, I must have seen 7 to 10 tails somewhere there. So another way of getting this exact same answer that we did here is I can do 1 minus p binom 6, 10.5. And that's going to give us that answer. Okay. So it's kind of neat, right? Saves us some work. And R is a really cool environment and language that you can learn and mess around with. I know I'm going to run out of time here, so let me just teach you a few last things, okay? The other function that we're going to use in this lab is p-norm, okay? When you put in p-norm, you can put in any value, okay? If you put in p-norm 0, this is essentially saying, look up in the table a z-score of 0. So p-norm 0 will give me what? 0.5, right? If I look up a z-score of 0, it's going to give me 0.5. And I can do, what's p-norm of a z-score of 1? And it gives me 0.84137. So if I do p-norm 1 minus p-norm -1, what is this going to give me? About 68%, right? Because this is the area between a z-score of 1 and negative 1. Okay, so it's giving me 68% there. Okay, and this is much more accurate. You'll notice it gives you a whole lot more decimal places than what your table gives you. Okay, and in your table, when we looked up a z-score of 1.333, I can do p norm 4 over 3, and it will give me a much more accurate number rather than what the table gives you, which was 1.33. You can also do, we can also ask questions like, what percentage of men are shorter than 6 feet? We can do 6 feet is 72 inches. The mean is 69.5 inches. And the standard deviation was 3 inches. Okay, so you can put in all three of those numbers. The height you're looking for, the mean, and the standard deviation. And it tells you that percentage of men are shorter than 72 inches, which means this percentage of men are taller. Okay? And again, if you have any questions, you can always ask the computer P norm. Okay? And then the converse of P norm is Q norm. Okay? Q norm says, give me back the z-score or give me back the height of this percentile. So what is Q norm of 0.5 going to be? 0. Q norm of 0.5 in the 50th percentile gives you a z-score of 0. Okay? So Q norm, what is Q norm of 1? Is there anything? It's positive infinity, okay? Because that's the only way to get 100% of everything under the curve, okay? But you can ask, okay, well, if a man is in the 30th percentile, so you do 0.30, and the mean height of men is 69.5, and the standard deviation is 3, how tall is this man? This man is 67.93 inches tall, okay? So this is Q norm. Okay, I know that was kind of brief and quick, but you can review just what I've done here on the video, and then I also have just a few instructions as part of your lab.